In this part of the video, we will have answers to the textbook exercise questions from gravitation chapter. The first question is, how does the force of gravitation between two objects change when the distance between the objects is reduced to half? The force of gravity between any two masses separated by r distance is calculated using this universal law of gravitation's mathematical formula. Say this is the force F1. Now we will apply the condition. The condition is a distance between the objects is reduced to half. So let R1 be the initial distance, and now when distance is reduced to half, then distance between the two masses be R2, which is half of R1. So the new distance between the masses is half the previous distance. Since any of these three quantities, if they change, the force of gravity also will change. So the new force of gravity between the masses, when masses are same but distance of separation between them has changed, is calculated as G m1 into m2 by r2 square, and this is G m1 into m2 by, in place of r2 we will write r1 by 2, so r1 upon 2 square. So the new force of gravity between the masses when distance of separation between them is halved is G m1 m2 by r1 square, which I am writing it as this, divided by 2 square, 4 will go to the numerator. Let us call the first force of gravity as equation 1 and the second force of gravity is equation 2. So whenever the question appears, what happens to the force of gravity when masses are changed or distance of separation is changed, we have to compare the two equations. Comparing means divide equation 1 by 2 or 2 by 1, any one of them. So we are following equation 2 divided by equation 1. So we will divide the left hand sides as well as the right hand sides. Left hand sides is F2 minus F1. Right hand side, what we'll do is, first we will write the equation for F2, that is 4G m1 into m2 by r1 square divided by F1. F1 is G m1 m2 by r square. So when we are dividing two fractions, denominator fraction can be written as a reciprocal if we convert a division to product. So this comes out as r1 square by G m1 into m2. This is for F2. What things cancel? Let them cancel. So all of them in fact cancelled except the number 4. So F2 by F1 is 4 upon 1, and which we can cross multiply and we can tell that F2 is 4 times F1. So the question was, what happens to the force of gravity if distance of separation between the masses is halved? So force of gravity becomes 4 times the initial force. So we will give a conclusion therefore. So force of gravity between the masses becomes 4 times the initial force of gravity if distance between the masses is halved. The second question is, gravitational force acts on all objects in proportion to their masses. The first line meaning is a kind of takeaway from Newton's second law, F is equal to ma. So force and mass are directly proportional. Force and acceleration are also directly proportional. So force and mass is directly proportional, means more mass objects experience more force of gravity. So the sentence is that gravitational force acts on all objects in proportion to their masses. If it is so, why then heavy object does not fall faster than lighter object? So if this is true, heavy object should fall on the surface of earth faster than lighter object, but that is not done. Why so? So here you have to connect to the statement that force of gravity and acceleration, they are directly proportional, and all objects are accelerated towards the planet with the common acceleration because force is common to all of them. So if objects start from the same time, from the same place, all objects should come on the ground together. Okay, so that is the reality. So I'm answering the question. Now they are saying that it is true that gravitational force acts on all objects in proportion to their masses. But a heavy object does not fall faster than lighter object. Its meaning is heavy object, light object, if they are dropped from the same place or same height at the same time, both the objects land on the surface of earth together. Reason, in the theory part I have discussed that they are accelerated with same acceleration due to gravity, and acceleration produced in the falling bodies is independent of mass of the falling bodies. It depends upon g m by r square, universal gravitation constant, mass of the planet and radius of the planet. So that is the answer, that heavy object don't fall faster than lighter object, they fall together. So here I have written one more, in a way the same answer. This is because Newton's second law, acceleration directly proportional to force, inversely proportional to mass. So ultimately acceleration is proportional or equal to F by m. So force, F is equal to ma, so force and mass are directly proportional. If force and mass are directly proportional, its meaning is the third physical quantity must be a constant. So here acceleration is constant. And what is this acceleration called? This acceleration is called acceleration due to gravity. So every freely falling object on earth or any other planet accelerate with a common acceleration due to gravity, which is constant, and this depends upon g m by r square. This formula we have already derived. So g is a constant, mass of planet is a constant, radius of the planet is constant. So every freely falling body falls with an acceleration due to gravity, which is a constant for a planet or a particular place. So heavy object, light object fall together. The third question is, what is the magnitude of the gravitational force between earth and 1 kilogram object on its surface? And we are given some data of mass of earth, radius of earth. This calculation I have done in the theory part. Force with which an object of mass 1 kilogram is pulled towards center of the planet, and that was 9.8 newtons. Since it has come once again in the exercise, I will solve it. Magnitude of force, we calculate force as g, mass of planet, mass of the object by radius of the planet square. So this is the formula, universal law of gravitation. Mass of earth we know, g we know, mass of object is 1 kilogram, radius of planet 6400 kilometers. So I am putting all the values, 6.67 into 10 to the power minus 11. This is in MKS unit. Mass of earth is 6 into 10 to the power 24 kilograms. Mass of the object is 1 kilogram. Radius of earth is 6400, but we'll write it as 6.4 into 10 to the power 6 in terms of meters. So how to solve this? Put all the numbers together and 10 to the powers together. So 6.67 into 6 upon 6.4 into 6.4 into 10 to the power minus 11 plus 24 minus 12, this one to the numerator. So here these two decimal cancel with this, because single digit, after single digit the decimal, and here also after 2 digit this. So the numerator is a set of numbers which we have to multiply, denominator is a set of number that we have to multiply. And here 10 to the power 24 minus 23, a good number of times done question. So the number is a kind of known number. So numerator is going to be 4002, denominator is going to be 4096 into 10 to the power 10. Now see, 40 by 40 is 1. Now if you cross the border of 40, you have a small number, but denominator is big. Whenever denominator is big, the fraction value is less. So this division when we do, it should be a bit less than 1. A bit less than 1, we can take it as approximately equal to 0.9998 or 97. So I am taking 98 into 10 to the power 1. So 0.98 into 10 means a decimal will shift one place. So the value of force of gravity is 9.8 Newton. So this is the answer to the question. The fourth question of the exercise is, the earth and moon are attracted to each other by gravitational force. Does earth attract the moon with a force which is greater or smaller or same force with which moon is attracting earth? So point is, by Newton's third law of motion, force between any two objects is always equal in magnitude and opposite in direction. So that can be any force in fact. So here whatever be the masses, quite unnecessary. The force or magnitude of force with which earth pulls moon is always equal to the magnitude of force with which moon pulls the earth. So answer is the same force. Earth attracts moon with what force? Moon attracts earth with the same force. And they are asking us a reason. Reason is by Newton's third law of motion. So we can write it as Newton's third law of planetary motion also we can say. Now the fifth question, if moon attracts earth, why does the earth not move towards moon? The point is by Newton's third law, with what force moon attracts, with what force earth attracts moon towards its center, with equal magnitude opposite direction force the moon attracts earth towards its center. So force of gravity is the same. But we see moon falling towards earth. Falling means moon revolving around earth. So that is what we call as falling towards earth. Means there is a constant centripetal force that is with which earth is pulling moon towards itself, due to which the tangential path of the moon is changed to circular path. Similar way, moon is also pulling earth with the same force, but we don't see earth moving towards moon because the mass variation. We don't see them, but it happens. So answer is the force exerted by earth on moon is used to change the path of moon from straight line to circular path. What does that mean? Its meaning is, I just draw it here and say, so this is earth around which moon is there. So every time moon is pulled towards center of earth by centripetal force, and every time moon wants to exit in a tangential direction. So that's the direction of displacement. But by the time moon orbit shifts, again earth pulls moon towards its center by inward centripetal force. Again moon want to exit in tangential direction. So this is exactly what happens for every object that is in circular motion. The object wants to exit tangential, but it is being pulled by inward centripetal force, and in that way the circular path is completed. So that is it. So moon, here I have written that the force exerted by earth on moon is used to change the path of moon from straight line. So every time the moon want to go in straight line, but its path is changed slowly and slowly in circular path. The moon attracts the earth with same force, but earth is too heavy to move towards moon. In fact, distance moved by earth towards moon is so small or too small to be detected. It is so small that its motion or movement is not observed or not detectable. Now look at question number 6. The question states, what happens to the force, means force of gravity, between two objects if we are given 3 bits. First bit is if mass of one object is doubled. That means only mass of one object is doubled, mass of second object remains the same, distance of separation between the masses also remains same. So we will answer the first bit followed by second bit. Second bit is when distance between the objects is doubled. So second bit has got 2 bits. Distance between the objects is doubled and distance between the objects is tripled. The third bit is when masses of both objects is doubled. So when they talk about masses of both objects is doubled, masses are doubled but distance between them remains same. So we will answer all these 3 bits one after the other. So starting with the force of gravity between the two objects. So first case, there is an object of mass m1 and then there is another object of mass m2. These are separated by some r distance. Distance means a distance between the centers. The question is, what happens to the force between the two objects if mass of one object is doubled? So the first state, what is the force of gravity between the objects? The force is F1, which is a G m1 into m2 by r1 square. So because the first condition, that's why F1 r1, we call this as equation 1. Now when one of the mass is doubled, so let m1 be doubled. So nu m1 is a double the initial mass. So here I have applied the condition. If either of the masses or distance of separation changes, force of gravity changes. So there is a new force of gravity, we call it as F2, which is G, the new mass, m1, the old mass m2 by distance of separation is the same. So distance of separation did not change, so still R1, or you can write R2 and later on R2 and R1 are same. Only mass, one mass is doubled. So here in place of this I'll write twice the initial mass, and this is equation 2. Whenever this kind of questions appear, we have to compare the two equations. Comparing means divide equation 1 by 2 or 2 by 1. So I'm following the instruction of dividing 2 by 1. You can divide 1 by 2 also. So divide the left hand sides, means F2 by F1 is same as F2's ratio is G. Okay, so that 2, this 2 I'm writing first. Then G m1 m2 by r square. G m1 into m2 by r1 square divided by F1's right side ratio. So instead of dividing, we can write product and the reciprocal of this. Whenever fractions are divided, we can write the numerator fraction as it is. Denominator fractions are reciprocal, we can multiply. So this is G m1 m2. This is for simplification process. So this cancels, this also cancels. Now F2 by F1 is a 2 upon 1. So what happens to the force of gravity if just one mass is doubled? It becomes a double the initial force of gravity. So we have to write a conclusion. The conclusion is force of gravity becomes a double. Force of gravity becomes a double the initial force of gravity. Now the same question, second bit has a 2 bits. So the second bit's first bit. What happens to the force of gravity between the masses if distance between the objects is a double? This is first part. Second part is a distance between the objects is tripled. Since they are talking about only distance and did not speak about the masses, its meaning is mass before and after remains same. So m1 and m2 initially were separated by some r distance, and the second case is when distance of separation between the masses is doubled. So distance between m1 and m2 is the new distance. The new distance is double the initial distance. You can even take r1, r2. I have taken small letter r, capital letter R. So first, the initial case, what was the force of gravity between the masses? Force of gravity was G m1 into m2 by r square. Let's call this as equation 1. Now distance doubled. So there is a new force of gravity between the same masses, G m1 m2. But the distance of separation is capital R square. So which I can take it as a 2r whole square. Twice r, and distance is doubled, but it is an inverse square law. So square remains. Equation 2. So whenever we are asked to compare, we have to divide. So now equation 2 divided by equation 1. You can also divide equation 1 by 2. But I am dividing equation 2 by 1. So dividing left hand sides, it is F2 by F1. Dividing right hand side, so this one. This is a G m1 into m2 by 2r whole square, means 4r square. This divided by this one means what? Multiply the reciprocal. R square by G m1 into m2. Just cancel this all, whatever things are getting cancelled, and it is 1/4. Now F2 by F1 is 1 by 4. Just go for a simple cross multiplication. So we are going to get F2, not cross multiplying, actually we have to tell F2 new force in terms of initial force. So 1/4 stays in the right side, 1/4, and only F1 comes the other side. So what happens to the force of gravity if distance between the masses is doubled? If distance between the masses is doubled, the new force becomes a 1/4 the initial force of gravity. But yes, of course. Why? Because if objects are far, gravity or force will be less between them. So here distance is doubled, force of gravity almost becomes 1/4. So conclusion, force of gravity becomes 1/4. Force of gravity becomes 1/4 the initial force of gravity. Now second bit. What happens to the force of gravity if distance between the masses is tripled? So this is the first case. Force of gravity between the two masses separated by r distance is sum F1. By universal law of gravitation, it is G m1 into m2 by r square. This is first case. Now distance between the masses is tripled. So the new distance is 3 times the previous case. So what is the force of gravity? Force of gravity is going to change if mass or distance of separation changes. So F2, which is a G m1 m2 as it is. Since in this question about masses nothing is said, its meaning is mass remains the same. Distance is tripled. So instead of r square, I should write capital R square. And what is capital R? Capital R is 3r. So here I am supposed to write 3r whole square. So this is equation 2. What we are supposed to do? Compare. Compare means divide equation 2 by 1 or 1 by 2. 2 by 1 is more suitable. So dividing left hand sides, F2 by F1. Right hand sides, first we should write F2's ratio means Gm1 into M2 by 9r square. 3 square is 9r square. Divided by this. Divided means just multiply the reciprocal of this one means r square by Gm1 into M2. Just cancel off this. We are getting 1 upon 9. So F2 by F1 is 1 by 9. So what is F2? The new force is 1/9 of the initial force. So what happens to the force of gravity? Force of gravity becomes 1/9 the initial force of gravity. That means if distance of separation is further, earlier it was a double, now it is a tripled, that much far. If objects are far, force of gravity reduces. So before it was 1/4, now it is 1/9. The third bit of the same question, what happens to the force of gravity if the masses are doubled? If they speak about masses, its meaning is a distance they did not speak, so distance remains same. So the first case, the force of gravity between the masses m1, m2 separated by r distance is G m1 into m2 by r square. I am not writing r1, r2 because in both the cases a distance of separation in the question doesn't talk about, means it remains the same. So this is equation 1. Now masses are doubled. So if any of 1, 2, 3 changes, force also changes. So the new force of gravity is a G capital M1 into capital M2 because mass is changed. Earlier I took small letters, now I am taking capital letters just to tell that masses are different. Distance of separation is same, r square. Here M1 is what? Twice initial mass. So I am writing here G twice M1 times M2. M2 is a twice initial mass by r square. So what happens to the new force of gravity? It is 2 into 2, 4 G m1 m2 by r square, G m1 into m2 by r square. Call this as 2. So we have two force of gravity. Now we have to tell what happens to the new force of gravity if masses are doubled. So once again comparing things. Equation 2 by equation 1. So dividing the left hand sides means F2 by F1. Right hand side is this one, 4 G m1 into m2 by r square divided by f1 fraction means a reciprocal to be multiplied. So G m1 into m2. You can do this, you can do this. This turns out to be 4 by 1. Now what is F2 in terms of F1? Just simple cross multiplication. So the new force of gravity between the masses, when masses are doubled, distance remains same, is 4 times F1. So we'll give a conclusion. If both the masses are doubled, the new force of gravity becomes 4 times the initial force of gravity. So force of gravity becomes 4 times the initial force of gravity if both the masses are doubled. Now seventh question, what is the importance of universal law of gravitation? First of all, universal law of gravitation is that law that holds true for everything in the universe, everywhere in the universe. And this is a binding force. That means this explains why things are connected to each other. And the answer to that is there in the textbook, which I have discussed in the theory part also, page number 134. So the force that explains, the force that binds us to Earth, makes moon revolve around Earth. Motion of planets around the sun is due to universal law of gravitation. What makes the tides rise due to moon's attraction or sun's attraction. So universal law of gravitation is true, and because of that we are able to understand these phenomena. Universal law of gravitation is universal. It holds true for everything in the universe, and this is the force that makes us to understand what makes us to bind to Earth, what makes moon revolve around Earth, what makes planets revolve around sun, what makes the tides rise during or at night or during the daytime. Question number 8. What is acceleration of free fall? So acceleration of free fall is that acceleration produced in every object that is dropped or thrown on a planet. Acceleration of free fall for Earth is 9.8 meter per second square. Its meaning is every freely falling body moves with a speed of 9.8 meter per second in every second. Question number 9. What do we call the gravitational force between Earth and an object? So this is quite a straightforward question. Gravitational force between Earth and an object is called Earth's gravity. Question number 10. Amit buys few grams of gold at poles as per instruction of one of his friends. He hands over the same when he meets him at the equator. Now will the friend agree with the weight of gold he bought? If not, why? And here they have given us a hint. Let's answer this. Since acceleration due to gravity is gm by r square, where g is universal gravitational constant, m is mass of the planet, r is radius of the planet. So acceleration due to gravity due to a place or a planet is inversely proportional to the radius of that planet, or a distance between that point and center of the planet. So these are in inverse relation. Coming to Earth. Earth is having more radius at equator and less radius at poles. So at equator, radius of Earth is more. And since these two are in inverse relation, if radius is more, acceleration due to gravity at a point on the surface of the equator is less. So g is less at equator. Since weight of the body is m into g, if g is less, because mass is constant, if g is less, weight of an object at equator is less. So weight of an object at equator is less. Using the same philosophy, we will understand that weight of an object at poles will be more. Why? Because radius of Earth at poles is less. Radius less means g is more means weight of an object at poles. Weight of an object at poles is more, and weight of an object at equator is less. So Amit took some gold from a friend at poles, and he returns the same gold at equator. So definitely gold's weight along with Amit's weight reduces by the time Amit reaches equator. So the friend has to understand this part of philosophy of science, that it was the same gold, there is no changes in gold. So the friend should understand that weight of an object reduces or changes from place to place as well as planet to planet. So if Amit understands that this is the relation between radius of the planet and g, and g's relation with w, then the friend will definitely understand that the weight of the gold, or the gold that Amit took from him at poles, is the same as the weight of the gold that he is returning to him at equator. Question number 11. Why will a sheet of paper fall slower than the one that is crumbled into a ball? Very simple. Sheet of paper has more surface area, so it experiences more air friction. In that process, it travels a long distance, whereas a crumbled paper has less surface area, it has got less friction, so it easily reaches the earth. So here surface area. More area results in more time of reaching the ground surface. 12th question, gravitational force on the surface of moon is only 1/6 as strong as gravitational force on the surface of earth. What is the weight in newtons of a 10 kilogram mass object on moon as well as on earth? So we have to find weight of 10 kilogram mass object on earth as well as moon. So first weight formula is W is equal to mg. So mass is 10 kilograms. G of earth is 9.8, or we can take it as 10 also. So kilogram meter per second is Newton. So 10 into 9.8 is 98 Newton. So that 10 kilogram mass object will weigh 98 Newton on surface of earth. Also on moon, weight is mg, mass is 10 kilograms. G of moon is 1/6 that of earth. 1/6 of 9.8 means 9.8 divided by 6 will turn out to be 1.63. Actually G of moon we have calculated in the theory part. So acceleration due to gravity of moon is 1.63 meter per second square. So kilogram meter per second square is Newton. So 10 times 1.63 is the decimal shifts one place, right? So 16.3 newtons. The 13th question, a ball is thrown vertically upwards with a velocity of 49 meter per second. So this is the initial velocity of throw. We are supposed to calculate the maximum height to which it rises. So the moment we see the word maximum height, we should understand that it has reached the maximum height where the final velocity of the object turns a 0. And because it is thrown in vertically upward direction, the ball is decelerating. So deceleration means G is a negative of 9.8 meter per second square or negative of 10 meter per second square. Next we have to calculate total time it takes to return to the surface of earth. That means we have to find total time of flight. Total time of flight is a time of ascent plus time of descent. That means how much time it takes to go to the maximum height and then how much time does it take to reach to the surface of earth. So time of ascent and time of descent are always the same. So we will calculate one direction time, means how much time does the ball take to reach the maximum height, and whatever we get, to that we multiply 2 or the same number we add to itself and we get the total time of flight. So let's solve. So 13th question, initial velocity of throw is 49 meter per second. We have to find maximum height to which it rises. So at maximum height, its final velocity turns 0. The object is decelerating. So minus or negative of 9.8 meter per second square. We have to find maximum height it attains. So these all in third equation of motion, v square minus u square is 2as, but here we'll write 2gh. So v is 0 and this is negative of 49 square. So 49 times 49, and here this is twice of negative 9.8 and h is our requirement. So in an equation, if there is a one unknown, we are going to get its value. So here this decimal I just make in fraction form. So 98 by 10. So 49 ones, 49 twos is 98, 2 ones and 2 fives. Now we'll do a simple cross multiplication to get h. So what is the maximum height attained by the stone or the ball? Maximum height is, we can cancel this. Okay, maximum height is, left side we have 49 times 5 divided by this single 2. So here 49 into 5, 9 5s 45, 4 in hand, 5 4s 20, 24 by 2. So we'll divide this, 2 1s 2, 2 2s 4, 2 2s 4.5. So maximum height attained by the ball is 122.5 meters. The same question has a second bit, total time of flight. So we will find time in one direction. We'll go for v is equal to u plus a t, and t is time of ascent. This is 0, u is 49 and a, which is actually g, is minus or negative of 9.8. So we will transpose this quantity. So we will get that as a positive of 9.8 times time of ascent is 49. So ultimately what is time of ascent? Time of ascent is 49 upon 9.8. This contributes a 0 to the numerator. So 49 upon 490 upon 98. 49 ones, 49 twos. So here we get time of ascent as 10 by 2 means what? 5 seconds. The question says what is the total time taken by the ball to reach to the ground? So here we know that since time of ascent is equal to time of descent, both of them 5 seconds. So total time is otherwise known as a time of flight. So time of flight is the time of ascent plus time of descent, which is 5 plus 5. So 10 seconds. So in 10 seconds, the ball goes to the maximum height and comes back to the surface of Earth. The 14th question. A stone is released from the top of a tower. Released from top of the tower means it is just dropped. So its initial velocity is 0. Height is 19.65. With this information, we have to find final velocity just before touching the ground. So here, this is the ground level and this is that maximum height of 19.6 meters. So from this location, the stone is dropped. Dropped means initial velocity of drop is 0. G is, actually I was about to take 10 meter per second square, but 19.6 is a multiple of 9.8. So we'll take it as 9.8 meter per second square. So we have to find final velocity just before hitting the ground. So you see, U, V, G, H, all of them are in third equation of motion. So we'll apply that. V square minus U square is 2AS means 2GH. So V is our requirement, so V square minus initial velocity is 0, so 0 square is 0, twice of 9.8 times 19.6. V square is twice of 9.8 is actually 19.6. 19.6 times 19.6 is 19.6 square. So what is the final velocity of the ball or the stone just before hitting the ground? It is 19.6 meter per second. Now 15th question. A stone is thrown vertically upwards with an initial velocity of 40 meter per second. So this is the U initial velocity, G is given. We have to find maximum height reached by the stone. Whenever we see the word maximum height, final velocity becomes 0. So with that we can find maximum height. But keep this in mind, if the stone reached maximum height, after maximum height it must have fallen down or dropped down to surface of Earth. So with that we have to inform or tell what is the net displacement. So from where the stone was thrown, it comes back to the same location. So net displacement turns out to be 0 because initial position and final position of the object is same. Next we have to calculate total distance covered by the stone. So we will find the maximum height and whatever is the maximum height in one direction, from there the ground is also at the same distance. So double the maximum height is the total distance covered. Let's solve it. So initial velocity is this, we have to find maximum height. For maximum height, what details? Final velocity is 0. The object is thrown up. So G is negative of 10 meter per second square. We have to find maximum height. Which equation? Third equation of motion. So we are using V square minus U square is 2AS, but we'll write 2GH. So this turns 0 and U square means 40 times 40 is 2 times negative 10 times H max. Negative cancels either sides. A 10, this one cancels. This is 2 ones, 2. So what is H? Right side there is nothing else other than H. So I'm writing that here. And left side we have 40 into 2. 40 into 2 is 80 meters. So H max, maximum height this object goes is up to 80 meters. But after reaching the maximum height, the object falls back to the ground. So initial position and final position are same, that is ground level. So the second bit of the question, this is the first bit of the question. Second bit of the question, so what is the net displacement? Net displacement is 0. The third question, what is the total distance traveled by the body? total distance covered by the body is from downward to maximum height 80 meters, and then from maximum height to the ground level is another 80 meters, and that is 160 meters. Now the next question, question number 16, calculate force of gravity between Earth and Sun, and these are the details given. We know that force of gravity between any two masses is calculated using the formula F is equal to G m1 m2 by r square. So here the two masses are mass of Sun and mass of Earth divided by distance between Earth and Sun or Sun and Earth square. So we have to calculate this. For this, this chapter is such a nice chapter where you should remember all these constants. What is mass of Earth? Mass of Earth is 6 into 10 to the power 24 kilograms. What is mass of Moon? 7.4 in 10 to the power 22. That means Earth 10 to the power 24, Moon 10 to the power 22, means 100 moons mass make one mass of Earth. In that way, correlate and remember. Mass of Sun 2 into 10 to the power 30 kilograms. Distance between the center of Earth and center of Sun is 1.5 into 10 to the power 11 meters. This is a very valuable number. This is called 1 astronomical unit. 1 astronomical unit is the average distance between the center of Sun to center of Earth, which is 1.5 into 10 to the power 11 meters. It's not 10 to the power minus 11. It's huge. 1 astronomical unit is the shortest distance of measuring stellar distances. Then there is something called light year. What is 1 light year? 1 light year is 9.46 into 10 to the power 12 kilometers. And then there is something called 1 parsec. And what is 1 parsec? 1 parsec is approximately 3.26 light years. So these are the stellar distances, celestial bodies distances are measured in terms of this. So force of gravity between Sun and Earth. So all these values, if you remember, well and good. So force of gravity is G is 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Mass of Sun 2 into 10 to the power 30. It's a rhyming also, we can remember. Mass of Earth is a 6 into 10 to the power 24 kilograms. All of them kilograms, fine. Divided by 1.5 into 10 to the power 11 meter square. So I'm writing 1.5 times 1.5 times 10 to the power 11 square means 10 to the power 22. How to solve this kind of numbers? Put all the numbers together and all the 10 to the powers together. But when I write the numbers, I will not write the decimal. So this I'm writing as 667 into 2 into 6, this one. Denominator 15 into 15. And here 10 to the power collection. Let's see. This contributes -2. This contributes this plus 30 plus 24. These two contribute 10 to the power plus 2. And this contributes minus 22. So this is how we have to put things in order. Then this we have to multiply. I just tell you, this is 225, that's fine. This is a big number. Just for a moment, I calculate that in rough and I'll come back. So 667 times 12 is 8004. 15 square is 225. 30 plus 24 plus 2 is 56. Minus 2 minus 11 minus 22 is minus 35. 56 minus 35 is 21. And here where I multiply numerator. Now when we divide this, this is going to be 8004 by 222. When we divide, we will get approximately 35.6. So 35.6. So this is 35.6 into 10 to the power 21. So this is the answer, but every time we write an answer, we have to give that in standard form. So here 3.56 into 10 to the power 1. And here already 10 to the power 21 is there. So force of gravity between Sun and Earth is a 3.56 into 10 to the power 22 newtons. And this is a nice number to remember. See, what is the force of gravity between Sun and Earth? Sun and Earth. force of gravity between sun and earth is 3.56 in 10 to power 22 newtons. Here you can remember one more additional information. What is the force of gravity between earth and moon? If you still remember, it is 2.01 into 10 to the power 20 newtons. So force of gravity between sun and earth is almost 100 times the force of gravity between earth and moon. So some comparative information. Now question number 17. A stone is allowed to fall from the top of 100 meters high tower, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. We are supposed to calculate when and where the two stones meet. So I have written the information in this paper. So here this is what happens. So this is the ground level, and there is a tower whose height is 100 meters. What happens in this situation? A stone is dropped from top of the tower. At the same time another stone is vertically projected upwards. When it is projected vertically upwards, it is projected with a speed of 25 meter per second, and when it is dropped, it was dropped with a velocity of 0. So we have to tell when and where do these stones meet. So let us draw a demarcation and just tell that this is the meeting point of the stones. So this is where, this is at some x distance from the ground level, say for example. In that case, this meeting point is at the total distance, that is 100 minus x distance from the top of the tower. So when they meet at a common time t. So time is common, but distances are different. So we will find x, then x will put here and we'll get 100 minus x, and we'll say that from ground level at this distance the stone met, or from top it met at 100 minus x distance, but the meeting time is same. So we are supposed to find time when they met, and place means x and 100 minus x meters from ground level as well as the top of the tower they met. So what we have to do is we will create two equations, one for the falling stone and one for the raising stone. So first for the dropped stone. For the dropped stone, what information we know? We know that it is initially dropped. G is 10 meter per second square. What distance did it travel? It traveled 100 minus x, and time taken, okay, we don't know. So that, like time when they met. And for this we can write s is equal to ut plus half gt square. Since initial velocity of drop is 0, this quantity becomes 0, and s is what? 100 minus x, and this one is a 10, so 10 by 2 is a 5t square. So let's have this as one equation. So equation 1, followed by this about the vertically thrown stone upwards. For the thrown stone, once again what is given? Initial velocity of throw is 25 meter per second. Acceleration is actually deceleration, so minus 10 meter per second square. What distance did it travel? It traveled a distance of x before meeting the second stone. How much time? That common time. So second equation once again, ut plus half gt square. S is a x, u is a 25, t is a time, g is a 10. So 10 by 2 is a 5t square. Fine. So this is equation 2. What we can do is, equation 2 we can substitute in equation 1. Means equation 2 x value, here we will substitute this. Or this equation we can write it as x minus 25t is equal to 5t square, and we call this as equation 2. So equation 1 and 2, right hand sides are equal, 5t square. So left hand side should be equal, we will equate them. So from 1 and 2. From equation 1 and 2. So we have here 100 minus x, right side x minus 25t. Done. So okay, so we came to a situation where we have two variables. Now for that, once check equation 2. Equation 2, the object was thrown upwards. If it is thrown upwards, this is a deceleration. So minus 10. G here is negative 10. So negative 10 by 2 is what? Negative 5t square. So this is negative. So at this step, we will multiply minus 1 throughout. As a result, this becomes negative and this becomes positive, and this negative 5t square becomes positive. So to this step, multiply minus 1 throughout. So the negative 5t square becomes positive. This becomes negative. This is transposed. Though it is negative, because it is transposed, this becomes positive. So 100 minus x, fine. But this one is negative x positive 25t square. You can cancel this. So 100 is equal to 25t. So what is a t? T is 100 divided by 25. So 4. So at what time do the two stones meet? They meet after 4 seconds of drop and throw. So this is one bit of the answer. Where do they meet? For that, we can go to equation 1 or equation 2. So I'm going for equation 1, which is comparatively smaller than equation 2. Equation 1 is 100 minus x is 5t square. Now t is what? 4. So t square means 4 square. So here just transpose these two. So we have here 100. X comes to the right side, becomes plus, positive x. 4 square is 16. 16 times 5 is 80. So 80 comes to this side, becomes a negative 80. So x is equal to 100 minus 80. 100 minus 80 is a 20. So at what distance from the ground level do the two stones meet? They meet at 20 meters above the ground. So come back to the diagram. So the question was, when and where do they meet? They meet at 4 seconds after drop and throw. So time is common time. X turned out to be 20 meters. So from ground level, the stones meet at 20 meter distance, and from the highest point, the stones meet at 100 minus 20, that is 80 meters. So 80 plus 20 is 100, that is the height of the tower. Question number 18. A ball thrown vertically upwards returns to the thrower after 6 seconds. This line means 6 seconds is the total time of flight. And remember, total time of flight is made up of time of ascent plus time of descent. Time of ascent and time of descent are always the same. So if 6 seconds is time of flight, then time of ascent, time of descent, both of them is total time of flight by 2, means 3 seconds each. So the ball takes 3 seconds to reach the maximum height. We are supposed to find velocity with which it was thrown up, means we have to find the initial velocity of throw u. Maximum height it reaches. Maximum height means we have to find h, but at maximum height its final velocity turns 0. And its position after 4 seconds means we have to find s at 4 seconds using the second equation of motion. S is equal to ut plus half gt square. So let's begin. Total time of flight is 6 seconds. Velocity of throw we are supposed to find. Okay. So first bit, time of ascent is total time of flight by 2, that is 3 seconds. The same is time of descent also. With what velocity it is thrown? No idea. And what is acceleration? It is actually deceleration, minus 10 meter per second square. So these all relates to first equation of motion, v is equal to u plus at, but in this case it is gt. Final velocity is 0, initial velocity is our requirement. G is a negative 10 and t is 3. So 0 is u minus 30. So minus 30, negative 30 transpose, then we will get initial velocity of throw as 30 meter per second. So with 30 meter per second speed, the stone was, or the ball was thrown upward. The second one, what is the maximum height it attained? Second equation of motion, v square minus u square is 2gh. Final velocity is 0, negative of 30 square. So 30 times 30 is 2 times negative 10 deceleration. So h max. H is our requirement. So here you can cancel this. This can be cancelled. 2 ones. 2 15s. So we have 15 threes 45, which is 1 into h. So max height attained by the stone is 45 meters. After reaching 45 meters, its final velocity becomes 0 and the stone takes a return journey towards the earth. Then third one, what is the position of the stone after 4 seconds? So we will use S is equal to ut plus half gt square. And what is a time in this case? A time is 4 seconds. So we have to find S at the end of 4 seconds. So S at the end of 4 seconds is ut. Initial velocity of throw is a 30, time is 4. It is thrown upwards, so g is a negative. So it is thrown upwards, so this is a negative 10. So this turns out to be negative 5 t square. Time is 4 seconds, so 4 square. So this is 120 and 16 5s 80. So this is 40 meters. So what is the position of the ball after 4 seconds? So after 4 seconds, it is at 40 meters distance from bottom. Meters from bottom. Why from bottom? Why? Because we have taken g as negative. That means from the beginning we have measured this distance. 19th question. In what direction does bind force on an object immersed in a liquid act? Bind force always acts in upward direction. That is the reason bind force is otherwise known as upthrust or upward force. 20th question. Why does a block of plastic released under water come up to the surface? Any object will come up or float in water if its density is less than water. So definitely the answer should be density of plastic must be less than a density of water. In that case, it will float. So plastic floats because its density is less than that of water. 21st question. 50 gram substance is 20 centimeter cube in volume. Volume of 50 gram substance is 20 centimeter cube. Density of water is 1 gram per centimeter cube or 1000 kilograms per meter cube. We are supposed to tell whether the object is going to sink or float. So using mass and volume, let us find a density of the substance. Density of the substance is mass per volume, which is 50 grams divided by 20 centimeter cube. So it is 5 by 2, which is 2.5 grams per centimeter cube. And since density of the substance is 2.5 and density of water is 1 gram per centimeter cube, so therefore if an object's density is greater than that of water, that object will sink in water. So therefore the substance or the object substance sinks in water. The last question of gravitation chapter, textbook exercise questions. The question is, volume of 500 gram sealed packet is 350 centimeter cube. The question is, will this packet float or sink in water if density of water is 1 gram per centimeter cube? Next, what will be the mass of water displaced by this packet? So let's answer. We are given mass and volume of that packet for which we have to tell whether it is going to sink or float. Since we know mass and volume, we can find the density of the packet. Density of the packet is mass per volume. Mass is 500 grams. Volume is 350 centimeter cube. Density of the packet is, if I divide 7 ones, some 1.4 approx it comes, this many grams per centimeter cube, which is greater than a density of water. Density of water is 1 gram per centimeter cube. So here we can give a conclusion whether the packet is going to sink or float. If density of a substance is greater than density of water, then that substance is going to sink since its density is greater than water. Then we have to tell when it sinks, what is the mass of water displaced. Whenever an object is placed in water, whatever is the object's volume, same volume of water overflows. Okay, so that we'll remember. So that was the first bit. Now second bit of 22nd question. We know that density is mass per volume. In that case, mass is a density into volume. So what is the mass of water displaced? So we have to find mass of water, which is a density of water into volume of water. Mass of water displaced is equal to density of water times the volume of water displaced. So density of water is a 1 gram per centimeter cube. What is the volume of water displaced? Volume of water will be the volume of the substance that is immersed in the liquid. If an object is immersed in the liquid, whatever is its volume, same volume of water will be displaced. And this packet has a volume of 350 centimeter cube. So whatever is its volume, same volume of water will be displaced by that packet. So volume of water displaced is a 350 centimeter cube, and you can cancel this. 1 times 350 is a 350 and grams. So what is the mass of water displaced by the packet? It is a 350 grams. And thank you for watching this video.